with a range between, as a unit between 1 up to 0. That's what we are saying. What am I saying in this? Am I saying the right thing? I'm saying that as per that equation, if eta P is equal to rho GQ into H minus KQ squared by rho GQ, which is equals to 1 minus KQ squared upon H, we are saying that eta at power maximum will be equal to 1 minus H upon 3 upon H, which is equals to 1 minus H upon 3 by 1 upon H. And that would translate to 2/3, which is 100%. And therefore we are saying this. When there is power transmission through a pipeline, for there to be maximum power, or for there to be maximum power being transmitted in the system, the efficiency of that system should downgrade to 67%, okay? Which is indeed a very great loss of energy. And that's why when that happens, for us to have a little bit of gains when we are running turbines, we do not allow the flow to come through this kind of a setup. You can see that because you have a single pipe connecting the reservoir up to where the turbine is located. We don't do that. We make sure that at the end of that pipeline, so that we can be able to achieve a bit of, or to get a bit of gains, we fit a nozzle, okay? We fit a nozzle because it is that nozzle which with increased velocity and power through the velocity of approach, if it's a Kaplan turbine, if it's a Pelton wheel, it can be able to hit the buckets and we rotate the buckets, okay? Otherwise, we are saying this. Let me put it another way. Pipes which are terminating with a nozzle will usually carry that water power from the storage reservoir to whatever end will be that is striking the buckets of a turbine. Okay? Otherwise, looking at the major loss due to friction in the pipeline, this is likely to affect the net head available for the turbine. Otherwise, what power developed in this case, we can be able to look at it when we have fitted a nozzle, is try to see what happens with the power maximum when we are transmitting through a nozzle. And this is how we work it out. If HV is equals to HF equals to 1/3 of H, HN, that is the head at the nozzle, is 2/3 of H, or 67% of H. That will be equal to 2 times of HF, which is equals to V squared upon 2G, and 2 times of FLV squared by D2G will be equal to Vn squared by 2G. But remember, your Q equals to A by V, meaning through the nozzle, the cross-sectional area of the nozzle times the velocity through the nozzle must give you the same Q because of the continuity equation. And therefore, we can say Vn squared by V squared, or Vn by V squared, equals to D raised to power 4 by Dn to power 4, which is equals to, if you work it out, to give you, it is equals to 2 FL by D, to imply that Dn, in this case, diameter of the nozzle, I want to change that, kidogo. Diameter of the nozzle when there is power transmission through the pipeline, will be equal to what? Will be equal to square root of b raised to power 5 divided by 2fl, 2 times of l square root, or 4 times square root of d to power 5 upon 2fl. That gives us the diameter of that nozzle, which you can be able to fit at the end of your pipeline, and then you have a power transmission to a maximum. Peradventure, you may run a turbine like the Pelton wheel. And I think it is for that reason we say, for the Pelton wheel, the efficiency is not so high. If you are running down with a nozzle, which reduces the efficiency up to 67%. Okay. Now, these are some of the things that you come across when you are pumping water and you'd like to transmit power through the systems. Sometimes when you are pumping water, and we have to account for the hydraulic gradient and the hydrostatic water pressure head and all that. Okay. This is the kind of a profile you have. Okay. Or else you can also plot the characteristic curve of the pipe versus the pump. Sorry to take you back to that. That is looking at the longitudinal section of the pumping main. When you have the hydraulic grid line and the characteristic curve, this is how you normally combine them. And you can show exactly what you are achieving with the transmission of power. In this case, when you are pumping through a pipeline system without, or you are trying to achieve maximum. When you are trying to achieve maximum power through that kind of a transmission. Otherwise, talking of pumping head, Mercy Mumbi, you are talking of that elevation head plus the friction losses, plus what I told you, H residual. And I told you H residual in practice should be equivalent to the atmospheric pressure at sea level 10.33. That is what we normally had. Then you can be able to get your pumping head. That is now when you reverse what we have here. What we have here with what you have here, because in this case, the flow is by gravity, and that is why we are getting all that. But in this case, you are trying to facilitate the flow by using a pump. Okay? This is the opposite of now what we have with a gravity flow. And with that, then I have an example for you. A penstock 60 meters long, 150 millimeter diameter. F is 0.02, laid at a slope of 1 into 100, carries water from a reservoir. And it terminates with a nozzle of 50 millimeter diameter. Coefficient of the nozzle is 0.95. When you consider all the losses, meaning minor and major, determine the discharge in the nozzle in LPS, liters per second. Pressure at the base of the nozzle, in the pump just behind the nozzle, the power in kilowatts at issuing of the jet, and then you draw the total energy and hydraulic grade lines. That is for Mercy Mumbi to spearhead. So this is what we have in that. That's your example and translation of your example. Okay. I've solved it a bit. Number 2, this is the next example is more or less like that. You look at that and that marks the end of our presentation. Any questions on that? Mercy Mumbi, any question on that? Any question? Any question on that? Guys, are you there? Any question on that, friends? You're not friends. Abdikadir, are you there?
Yes, I mean.
Any question, Abdikadir?
I have no question.
Hii sio ile ya kuuza ama kuchunga ngamia, is different. Unasikia Abdikadir? Ukienda ukawambia wale wazee siku hizi nimeona mbali sana. Nasikia Abdikadir. So, what of Angel Celia? Amenyamaza sana. Angel, are you there?
Yeah.
Are you okay, Angel? Because I want to
Yeah.
mention.
I'm okay.
You're okay. I hope you're okay. You sound like you're sleeping when you're okay.
No.
Wewe. Hey, chunga sana. Laura Batila, are you okay? Laura. Wewe sema yes tu. Lakini tutakutana in measurements. There's a unit we used to call measurements, estimating and costing. But I'll be meeting you for measurements in psychometrics very soon. Brandon Kimutai.
Yes.
Hii sio kama kukunywa murusik. Unasikia?
Yes, nimesikia.
Hiyo weka mbali sana.
Sawa.
Sio chego. Bravin Miche. Bravin.
Yes, sir.
Are you okay?
Yes, I'm okay.
Kwemoi. Matasero. How come you have not been answering my questions? Okay, Brian Bisonga.
I'm okay.
Leo ulipona kwa maandamano tukikutana. Brian Kithuka.
Yes, I'm okay.
Okay, Bulinda, Eugene Wamalo. Are you there, Bulinda?
Yes, I'm here.
Good. Carlos, the man. Where's Carlos, the man? Carlos.
Yes.
Wewe wacha mchezo uonekane.
I'm here.
Charles Kiarie. Leo aliingia sijui saa ngapi Kiarie. Kiarie, are you there? Wewe nyamaza tu tutaonana. Collins Omondi. Collins.
I'm here, sir.
Good. Abunga Crispin. Are you there, Crispin?
Yes, I'm here.
Thank you. Desmond. You cannot be Victor Kaplan. But we can allow you to change your name to Desmond Victor Kaplan. Okay? We promote you na wambia jamaa wa kuongope. Pata hiyo jina. Douglas Maburi.
So.
Good. Boyanzi, you are there?
Yes, I'm there.
I told you we have a lot to talk.
We will.
Elizabeth Wajiko. Shiko.
Yes.
Wiko.
Yes.
Okay. Any questions?
No questions.
Good. Emmanuel Zachariah, are you there, Emmanuel?
Yes, sir. I'm here.
Esbon Baron. Esbon, what is Baron? What is Baron? What is Baron? Do you know what is Baron?
Yeah.
What is it?
Baron.
I know you're Baron, but what is Boron? There's also Boron. What is Boron? Yeah? You don't know? Yeah?
Element.
You don't know?
Element. I know.
Huh?
I know it's an element.
Of. Wait until you meet me in an interview panel. You think I'm not in the industry? Utanikuta huko tu. Hunter Muriuki.
Yes, I'm here.
Good hunter. I know what you're
Yes,
hunting.
yes.
I know what you're hunting with me. Jacob Wambua. Wambua. Hey, where is this Wambua man?
Yes, sir.
Good. James Oyuko. James Oyuko.
Oh, yes. Yes,
Joan.
Yuko.
Good. Say, Joan, are you there? Joan?
Yes, I'm here.
Thank you. Josh Kamau, the man.
I'm here.
Good. Kiprotich. Alan.
Yes, I'm here.
Raula Assumpta. Are you there, Assumpta? Laura, are you there? I hope you are not hiding, and the way I fear the name Assumpta. I don't know why. I fear anyone with that name. Mercy Mumbi, she has talked. Miriam Jacks. Yeah. Kumbe tuko.
I'm there.
Thank you. Nyongesa Evans. Well, Nyongesa aliingia kama. Aliingia saa ngapi?
I'm present, sir.
And Okwanyo, hey, the man from Migori. Okwanyo, are you there?
Yes, I'm in.
Oh, thank you. What of Owen Richards? Atakiwa yeye ni mzungu atatukuta tu. Owen Richards, are you there? Owen?
Yes, I'm there. I'm present, sir.
Good. Philemon Masha?
I'm present.
Sandra Kiptum? Yeah.
I'm here.
Thank you. Stancy Kyoko, are you there?
Yes.
Any Teddy Smith?
Yes, I'm in.
And Timo Munene? V Nyaboke came late. V, are you there?
Yes, I'm here.
Kwa nini uliingia mara mbili? Or you wanted to stamp your authority? Okay, Zedekia Magara. Zedekia? Where is Zolabudi Osano?
I'm here.
Thank you. Abdikadir, ukiona kuswai, muuliza ako wapi siku hizi kwa sababu simuoni vizuri. Ikiwa naenda kuuza ngamia au akimpatia report, ndio akikuja to share the proceeds. Hiyo nitanyamaza ikiwa you share the proceeds. Ikiwa hata share proceeds, hiyo tutaongea. So thank you so much. We meet. When can we have a cut for both? Can you discuss when we can have a cut? One day we pick a day, we have a cut, one after the other. One question enough for you, or big enough to your size. So Victor, you can discuss. Tell them these days you are Victor Kaplan Desmond Tutu. So discuss with them, let me know. We have done to the syllabus so that I can give you